Hello. So here we are at 4.2, and it is on page 201, binomial distributions. Okay, so for the definition of a binomial experiment, we've got these four conditions that have to be satisfied. And those are in the definition box on page 201. We have to have a fixed number of trials. That is an n value. Two possible outcomes, one being a success, one being a fail. P is the success and fail is the Q. And one thing we need to understand here is that Q is equal to 1 minus P. We do need to understand that and how to find Q in order to be able to identify what the Q value is. Number 3, the probability success is the same for every trial that you perform in this experiment. And number 4, the random variable counts the number of successes, and that is the random variable is X. And as we'll see, X and M are directly related. So we are going to start with being able to identify whether or not an experiment is binomial by looking at example 1 on page 202. Okay, number 1, we have a certain surgical procedure. It's got an 85% chance of success. So for your example 1, your p-value, your success, is 0.85. That means that your Q value is going to be 1 minus that, which is 0.15. A doctor performs the procedure on 8 patients. So the number of trials, N, is 8, and the random variable represents the number of successful surgeries. So we could have 0 successful, 1, 2, 3, etc., all the way up to 8. Okay, that is a binomial experiment. Now, if we read example 1, number 2, we've got a jar with 5 red marbles, 9 blue, 6 green. You randomly select 3 marbles from the jar without replacement. That very definitely is counter to number 3 in our constraints. If we don't put back the marbles that we choose, we are altering the success of each subsequent trial. So we can tell that example 1, number 2, is not a binomial experiment. Okay, easy enough. Now we're looking at try it yourself 1. You take a multiple choice quiz that consists of, so this is the try it yourself 1. I don't know how else to, let's stick an I in there, whatever. You take a multiple choice quiz that consists of 10 questions. N is your 10 questions. Each question has 4 possible answers, and only one of those 4 is correct. So, of course, considering that you would want to get the correct answer, 1 out of 4 would be your success. Therefore, 3 out of 4 would be your fail. So P is 1/4, Q is 3/4. If you add those together, you get a 1. And to complete the quiz, you randomly guess the answer to each question. The random variable represents the number of correct answers. So this is where I said X and N were directly related. If you have 10 questions, the random variable representing the number of correct answers could be anywhere from 0, right, out of the 10, to all 10 right. And of course, those little dots mean 4, 5, 6, 7, 8, and 9. Okay? Now, we did not have anything that altered the way that you answer from one question to the next. So this is a binomial experiment. Simple enough. Okay. Now, the binomial probability formula. I am going to give you guys a break, and what we're going to do is go right to using technology for something like this. Okay, so what you're going to need to do is get your calculator out. The first thing that we are going to do to get to the program that we need is we are going to hit the second key, and from there we are going to hit the 0, the number 0. And then from there, what you're going to do is hit the apps button, because that is going to bring you directly to the B's in your catalog. And then you are going to arrow down until you get to BINOMPDF. So once you arrow down to there, you are going to hit enter. Okay, so I'm going to leave these instructions up here, and I will show you how to use this program instead of that formula. Okay, so we're going to jump right down to the try it yourself. When you use the technology and you follow all of these steps in succession, your calculator is going to open up BINOMPDF with a parenthesis. What you enter in here in order is N, comma, and the comma is right above the 7 key. Then your P value as a decimal, and then the X value. And then you hit equals, and it will give you that binomial probability. Okay, so we're going to look at Try It Yourself 2. And we're going to use this calculator thing instead of the torture for filling in that formula, okay? Eventually, in the next example or two, we're going to end up learning how to use technology. So instead of going through this, knowing that we're not going to do this formula while we do the homework, we're going to jump right to the program. So Try It Yourself 2, bottom of page 203. A card is selected from a standard deck and replaced, okay? So we know that the success of each successive trial is not affected when you replace a card. The experiment is repeated 5 times. So N is equal to 5. Find the probability of selecting exactly 3 clubs. Well, the probability of getting 1 club is 1 out of 4, because we've got 1 suit that's clubs and another 3 hearts, spades, and diamonds. So the probability of getting 1 club is 0.25. Okay, now the X value is found in selecting exactly 3. So our X value is equal to 3. So in our binomial program in our calculator, we are going to enter in 5, comma, 0.25, comma, 3, and hit equals. And you get 0.088. That is the probability that you will get exactly 3 clubs when you perform that experiment. Okay? Which is going to make our work immeasurably easier. Okay, so remember that, write that down, and make sure that you have that, that set of rules, so to speak, so you can perform that with every example and every homework problem that you're being asked to find the probability of a binomial experiment. Okay, moving on. We are looking at example 3, constructing a binomial distribution. Okay, so we are going to jump right to the Try It Yourself 3 on the bottom of page 204, and we will be using our calculator again. Okay, so for Try It Yourself 3, we have 7 adults who participated in this survey. So N is going to equal 7. And they are asked whether they use a tablet to access social media. So if you look at the figure underneath example 3, how do you access social media? Tablet users are at 16%. So our p-value is 0.16. Okay. And then it says construct a binomial distribution that is a table, like what you see off to the left of this solution. That's a table. That is your binomial distribution. That's what we're going to construct, but we're not going to use the formulas. We're going to use our calculators, okay? So it says construct a binomial distribution for the number of adults who respond yes. Okay, so of course, X being directly related to N, we could have 0 respond yes, 1, or 2, or 3, or 4, 5, 6, or 7, okay? So what we're gonna do is we need to use this calculator program 7 times, okay? Because the X values that we have go from 0, no, we're gonna use it 8 times because we need to include that 0. Sorry about that. Okay, all right, and then the probability. So remember, we'll walk through this. You are going to hit second, 0, apps, and arrow down to BINOM PDF and hit enter. So if when X is 0, what we're going to enter in, 7, comma, 0.16, comma, 0, and hit equals. And we get 0.295. So let's do 3 decimals for each one of these, okay? Now we're going to do the exact same thing. Second, catalog, apps, arrow down, enter, 7, comma, 0.16, comma, and then a 1. And we get 0.393. Now, isn't this wonderful? That way we don't have to worry about going through that hugely long ordeal. I did do it by hand and it was horrific. So when X is 2, we get 0.225. Okay, so we're going to do it again. While it might seem like a huge pain to have to go through the keystrokes every single time, trust me, it's way better than having to do this by hand. Like I said, I did do it by hand and it took a very long time. So now we're on X of 4 and we get 0.014, again, rounding to 3 decimal places, okay? And it goes very quickly once you get the keystrokes and you remember how to work them very quickly. These do go by very quickly. 0.002 is when X is equal to 5. And what we're going to find, I believe, is that 1 or 2 of these answers are going to give us your scientific notation, which is this, when x is 6, we get 9.86 or 9.9 times 10 to the negative 5th. So that would be 4 zeros in front of that 9. So 0.00000, and I'm just going to do 0.000099. So we don't have to worry about rounding the nines, because those get a little bit tricky when you've got that many zeros there. Okay, last one, 7, 0.16, 7, and we are going to get, again, a scientific notation number. So it'll be 5 zeros now, 0.01, 2, 3, 4, 5, and that we'll round that one to a 3. Okay, now the idea is that when you add all of those together, you should get a perfect 1. However, because we rounded, we would not get a perfect 1. We're going to get, say, 1.000 with some other random numbers that are not zeros. But that's okay. All right? Because we rounded, we will expect to not have a perfect 1. Okay. So, remember, using your calculator is going to be a huge help. Now, moving on to page 205, that is where they tell you how to use your calculator to figure out your binomial probability, okay? We already know that, so we are moving on to example 5. Okay, and again, have those calculators charged and ready. All right, we're going to jump down to try it yourself 5. It says the survey in example 5 found that 53% of men believe there's a link between playing violent video games and teens exhibiting violent behavior. So that is our p-value. P is 0.53. 53% as a decimal. You randomly select 5 men. So N, and I'm going to stick that up here, just so we put them in our calculator in order. N equals 5, and ask them whether they believe that there is a link. All right, find the probability that 1, exactly 2 of them respond yes. So our first X value is going to be 2. The second X value is at least 2 of those 5, okay? So at least 2 of the 5 would be 2, 3, 4, and 5. And the third part of this is fewer than 2 of them, which would mean 0 and 1. Okay. Now we're going to use our calculators here, and for 1, okay, we're going to open up our binomial distribution, 5, 0.53, 2, and hit equals. And you get 0.292 rounded, okay. Now that's easy. When we get to parts 2 and 3 of this, we are going to have to do some adding, okay? So we're going to do that same thing for 2, 3, 4, and 5. We already know that 2 is 0.292, and then to that, we are going to use an X of 3 and add that in. We're going to use an X of 4 and add that in, etc. So we still have 5, 0.53, and then 3. And that gives us 0.329. So you guys should be doing this along with me, so you know that you're getting the exact same answers that I'm getting. So when you do this by yourself, you won't have any problems getting this done. And when x is 4, we have 0.185. And the last one is when x is 5. So 5, comma, 0.53, comma, 5, and you get 0.042. So of course, what we are going to do then is add all of those decimals. So 0.292, so we're going to add all these decimals together, and that would be our answer. And when you add those together, you get 0.848. So for part 3, we're going to do the same thing, but we're going to use the first value of x as a 0. So 5, comma, 0.53, comma, 0, and you get 0.023, to which we are adding the x value of 1. Okay, so 5, comma, 0.53, comma, 1. Enter. So 0.129. And add these together. And you get 0.152. Okay? So when it says write the result as a sentence, you are looking that for number 1, the probability that 2 of these men will respond yes to that survey is 29% about, okay? The probability that at least 2 of the 5 will respond yes to that survey is almost 85%, and the probability that 0 or 1 respond yes to that survey is about 15%. In other words, most parents, men at least, feel that violent video games lead to violent behavior in teens. That would be interpreting the results. Now, for example 6, we're going to go to the probability table. I just want to show you where it is. It is in the back of the book. When you locate page, let me see where mine is, A8, you have a binomial distribution table, page A8. It's in the back. So the farthest left, along the top, you've got N, X, and then all those decimals that you're seeing are the p-values, okay, as opposed to Q. So let's hold your finger in page A8, and we're going to look at using that table for the try it yourself 6. So it says about 55% of all small businesses in the U.S. have a website. That is your p-value. Okay, my recording stopped and I'm not exactly sure where it stopped, so please forgive me if I sound like a moron, okay? We're going to use, I'm just going to start example 6 all over again. I do apologize. We're using the table in the appendix, and it is on page A8, okay? So for that, we're going to utilize example 6, try it yourself 6. It says 55% of small businesses in the United States have a website. That is your p-value, okay? So p is going to equal 0.55, okay? And it says you randomly select 10 small businesses. That is your n value, okay? The probability, what is the probability that exactly 4 of them, so x equals 4, have a website. So when you turn to page A8 and A9, the first thing you're going to do is locate your N value. That's at the very top of page A9, where N is 10. The next thing you're going to do is go to the X column and go down to a 4, and then follow that to the right until you are under the P value of 0.55. Under that, when X is equal to 4, you see a decimal or a probability of 0.160. So if you do that on your calculator, which I am going to do right now, okay, we're going to use our binomial probability program. We are going to enter 10, comma, 0.55, comma, and 4 equals, and we get 0.1595, which to 3 decimals is 0.160. So that would take place of your calculator, say if your calculator was dead or if you forgot it at school. Okay, now graphing a binomial distribution is what we're looking at in example 7. And again, we will be using our calculators for this. So we're going to jump down to the try it yourself 7. A recent study found that 19% of people, so that's our P value, so P is equal to 0.19, in the United States own an e-reader. You randomly select 4 people. That's our N value, okay? And it asks you to construct a probability distribution for the random variable X. That's the table. And then graph that distribution. Well, being that X is directly related to N, X is going to be 0, 1, 2, 3, or 4. So we'll put that in a table, and we are going to use our calculator for this, that binomial distribution program. Okay, so again, going through these steps here, we enter in 4, comma, 0.19, comma, 0, and we get 0.430. Okay, and we're going to do this for all 5 of these, sorry. Okay, and when X is 1, we get 0.404. So I really hope that you are doing this along with me, because besides the distribution that we're filling out right now, we also have to create a histogram, okay? So we're going to keep going until we finish the probability. And one more. See how quick this goes? When I did this by hand, I said, oh, there is no way that once we learn how to use our calculator, there's just no going back. I mean, it's just not going to happen. So, okay. Now, the idea again is if we were to add these up, they would be very close to 1. All right, so here we're going to add it up just so I can show you what I mean when I say that rounding tends to skew. The more you round, the more inaccurate your answers are going to be. Okay, so when you add these 3, you get 0.999, which of course is about as close to 1 as you're going to get. Okay, so now we are going to construct a histogram. Okay, so your histogram, it's going to have the number of those. It says you randomly select 4 people. So those are the X values. You'll have 0, 1, 2, 3, and 4. That is, we'll just put people 16 plus. That's who was surveyed. And then the probability, P of X, goes along your y-axis. So you've got 0.001 up to 0.4. So let's just do 0.05, so 5, 10, 15, there's a decimal there, 20, 25, 30, 40. Whoops, that's supposed to be, that's not where it's supposed to be. Let's make sure we get it lined up just about. And then we have 0.4, 40, and then 0.45. Okay, that the highest number is 0.43. Okay, so when we have 0 people, we are at 0.43. So that height is right about there. Okay, so I'm going to go up. And then when X is 1, we're almost exactly on the 0.4. And again, you guys will be using graph paper for this to make sure, or you should, to make sure that your lines are nice and straight. Okay, and 3 is 0.022, 0.0, so that would be, say, right about there. And then 0.001 is, almost on the ground, so to speak. Okay, so that is your distribution there, okay? You've got your distribution table and then the histogram that goes along with it. So when it says describe its shape, remember, if it's a normal bell curve, it would be shaped with symmetrical distribution, right? With the highest in the middle where the mean is. Ours, however, has a little bit of a tail. And remember, the way that you say it's skewed is which way is the tail. The tail is to the right, so our graph is skewed to the right, or just skewed right. That is the shape of the graph. Okay? And when it says, are any of the events unusual? Remember, unusual events are where our probabilities are less than 0.05. So we have 2 unusual events here, where X is 3 and X is 4. Okay? So that means that it's unusual for 3 or 4 people to own an e-reader. Okay? 3 or 4 of those people age 16 or over. Okay, so the last thing, thankfully we get a break here when it comes to mean, variance, and standard deviation. If you look at the top of page 209, our mean is N times P. Our variation, and this is population because we have these variables that suggest population as opposed to a sample. So the variation is N times P times Q, and then the standard variation is to take the square root of that, okay? So no longer do we have to worry about constructing the squares and the sum of the squares and all that stuff. It is so much simpler than that. So we're going to go down to try it yourself 8 and answer these questions. It says in San Francisco, California, about 44% of the days in a year are clear. And I don't think that they mean sunny. I think they mean clear as opposed to a lack of smog or pollution. That's what I'm thinking. That's our p-value. So p is 0.44. And it says find the mean, variance, and standard deviation for the number of clear days during the month of May. Well, the number of days in May is 31. Okay, so remember the Q value is going to be 1 minus the P value. So Q is going to be 1 minus 0.44. That is 0.56. So when we're looking for the mean is going to be 31 times 0.44. It is that simple. So the mean, 31 times 0.44 is 13.6. It's 13.64, but we can use one decimal. And then our variance is multiplying all three of those values together. So it's the same thing. So we can leave our 13.64 and multiply in the 0.56, and then we would get our variance, which is 7.6384. Now I'm going to use all of the decimals for that because we will need to take the square root for the standard deviation. And when we do that, then we'll round to 1 decimal. So the standard deviation, taking the square root of the variance, is 2.76. We'll round it to 2.8. All right, so now we found the standard deviation. When you interpret the results for part E, the results would be interpreted as, on average, there are about 13.6 clear days in the month of May in California, okay? And the standard deviation is about 2.8 days. Now, remember that the norm, when we talk about standard deviation, is when values are within 2 standard deviations. So it says determine any unusual events for part F. So our unusual event would be the mean minus 2 times the standard deviation. That is going to be less than 2 standard deviations, or 13.6 plus 2 standard deviations to the right. So 13.6 minus 2 times 2.8 is 8. And then 13.6 plus 2 times 2.8 is 19.2. Okay? So if you have, it would be unusual to have a May with 8 clear days, 8 or less clear days. Likewise, it would be unusual to have a May in California where you've got 19 days or more that are clear, okay? So in between 8 days and 19 days is where you're going to find that the majority of your data is going to fall. Because remember, greater than the 2 standard deviations or less than the 2 standard deviations is unusual. Okay, now here is your homework, okay? Writing it down for 4.2. We have, and you can use your calculator for all of this. All of these that say, find the probability. Oh, that's supposed to be a 24. finding the probability and constructing probability distributions and all that good stuff. Use your calculators. Okay? Those are the numbers that you are responsible for. Since this lesson is on Tuesday, these will need to be presented to me via email, unless somebody there is going to be grading them, but I have the key, by Wednesday, before class. Okay? These are not that difficult. All right. Have a good afternoon, guys. Bye.